Okay, 6.5, the quadratic formula. If you take your quadratic formula, which is this right here, the x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant, let's talk about the discriminant and do a couple problems. The discriminant is what is underneath the square root. So it's going to be this b squared minus 4ac. And the discriminant is pretty sweet because it is, let's see, what's sweet about the discriminant is that it can be used to determine the number and type of solutions. So the table, you've got a chart right here. It doesn't make much sense, but if we give you some examples of problems, it'll make a ton of sense. So to the left, let's write an example, and I'm going to do this, let's call this 1, 2, 3, and 4. So example for number 1. Okay, the value of the discriminant, b squared minus 4ac is greater than 0. So that means this, it's what's under the square root. So if you have under the square root, it's got to be greater than 0, so it's got to be positive. It's like a 36, a square root of 49, square root of 100, square root of 25. Okay, under the square root, those are all positive, but also those are perfect squares. If you do the square root of 36, it's going to give you 6, and etc. So under your square root, if it is a sweet number that happens to be positive and a perfect square, then let's go to this column right here, the number and type of roots. You're going to have two real rational roots. And what that's going to look like is this. You're going to have a parabola, and it is going to go through the x-axis 2 times, once right here and once right here. So look at this guy, x squared minus 8x plus 15. If you graph that, it looks just like this. So what we're trying to show you is the graph gives you the answers. If you've got a parabola, it's going to go through the x-axis right here at 3 and right here at 5. So we're saying that your solutions are x equals 3 and 5, and those are the roots of this quadratic equation. So if you take y equals x squared minus 8x plus 15, and if you factor it, you're going to get y equals x minus 3 times the quantity x minus 5. Okay, now here's what I'm interested in. I'm interested in putting a 0 in place of y. So if y is 0, what is x going to be? Now, if you're multiplying these two quantities and your answer is 0, use the zero product property. One of these has to be 0. So either the first quantity or the second quantity has to be 0. So what would make the first quantity 0? X is 3. What would make the second quantity 0? X is 5. Alright, sweet. So our answers do match up. We do get 3 and 5 for an answer. But now the quadratic formula. So if we use the quadratic formula, you've got to know A, B, and C. So A is always the number in front of the x squared. A is going to be 1. B is the number in front of the x, that's the negative 8. And C is the constant, the number all by itself, so that's 15. Now, let's plug it in. X equals negative b plus or minus the square root of b squared, that's going to be 64, minus 4 times a times c, that's going to be 60, all divided by 2 times a. So what we're talking about with the discriminant is this. The discriminant is going to be this guy right under here. And if I simplify it, it's going to give you the square root of 4. Now, square root of 4 is a perfect square. So that means my answers are going to be on the number line, and they're going to be rational numbers. They're going to be these nice numbers, 3 and 5. So they're not going to be any funky decimals, any imaginary numbers. They're going to be nice, easy, sweet numbers. So if your discriminant is positive and if it's a perfect square, then those are the easiest. Those are the ones we love the very most. Here's example number 2. So let's do example number 2. Okay, your discriminant still positive, but what if it's not a perfect square? What if it's the square root of 5 or the square root of 7 or the square root of 20? There's a whole bunch of square roots. Most of them are not perfect. So what happens if it is a square root of 5 or square root of 7, square root of 20? Okay, you're still going to have 2 answers, but what are your answers going to look like? Your answers are going to be irrational. They're going to be decimals. They're going to be decimals that go on forever with no pattern, and they're a little bit more tedious. They're kind of a pain in the butt. It still looks like this. They're still going to land right here on your x-axis, but they are going to be decimals. They're not going to be the nice, even integers. So let's see if we can find one that looks like that. Let's number 2. Okay, look at number 2. Number 2 is awesome. That lands on 1 and that lands on a -3, so that's nice and clean. 3, 4. Looks like they... Okay, here's one. Here's what I'm talking about. So look at your answers on this one. Your answers are right here, somewhere between 4 and 5, and somewhere between 1 and 2. So they did not land right on a nice whole number, an integer. So let's do this real quick. Let me show you A, B, and C. A is 1, B is -6, and C is 6. So it's going to be x equals a negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, or 2 times 1. Okay, your discriminant is just what's under the square root, so it's just this part right here. 36 minus 24. 36 minus 24, so the discriminant is the square root of 12. And the square root of 12 is not, that's not a perfect square. It is positive, so I'm going to have 2 roots, but my 2 roots are not going to be integers. They're not going to be whole numbers. They're going to be irrational numbers. So if you see your discriminant is not a perfect square, it's going to give you 2, we call them irrationals. Those are irrational numbers. 2 irrational roots. Okay, let's do another example. Example number 3. If your square root is, if your discriminant is square root of 20 minus 20, if you ever end up with a 0, then your answer is going to be 1 real root, and it is going to be rational. So it's going to be just like number 1. They're going to be sweet. Those are the nice numbers that we love, rational numbers. And it looks like this. So your parabola is going to sit right on top of the x-axis, or it could, well, let's pretend that hit the x-axis. It could go right below it. It could be a frowny face. But your vertex is going to sit right on that number line, so it only touches it once. Okay, the last type, example number 4, is this. What happens if your square root underneath your radical, you have a negative number? So square root of a negative 20. If you ever come across your discriminant and it's negative, that means that you are now in the world of imaginary numbers. So your roots, you're still going to have 2 of them, but they're going to be complex roots. And what that looks like visually is this. Your parabola is not going to even touch the x-axis anywhere, because your x-axis is a number line, and it holds all the numbers, all the positives, negatives, decimals, fractions, but it does not hold the imaginary numbers, the complex. So your parabola is never going to touch the x-axis. It's going to float above it, or it's going to float below it, but it's not going to touch it. So the discriminant is what's underneath the square root, and that tells you what type of graph you're going to look at and how many roots you're going to anticipate. So let's use it in a problem. Practice. Okay, sketch the graph of a quadratic equation whose discriminant is positive. So if you make a coordinate plane, an x-axis and a y-axis, the discriminant, that's what's under the square root. So if under the square root, if I have something that meets the criteria of A, if it's positive, like 16, what is it going to look like? And just go back to your chart here. It's going to look like either example 1 or example 2. So it's going to look like this guy right here. It is going to have 2 roots. Okay, B. What happens if it's negative? Underneath your square root, if you've got a negative 20, well, that is going to look something like this. It's going to be a parabola, but it's not going to touch your x-axis. It could be close to it, but it's not ever going to touch it. 0. What if your discriminant is 0? So the square root, under the square root, you just ended up with 0 after everything's simplified. Okay, it's going to look like this. You're going to have a parabola that just touches the x-axis right at its vertex. So it doesn't go below and like A and come back up and touch it in a different spot. It just hits it once on the vertex. So your worksheet has problems just like these. And you've got 3 sets of instructions. A, you need to find the discriminant. B, determine the number and type of roots that your equation is going to give you, and then C, find those roots. So let's look at this first guy. X squared minus 16x plus 4 equals 0. Alright, let's determine our A, B, and C. Let me change colors. A, B, and C. A is that number right there, it's 1. B is a negative 16. C is 4. So now just plug it into the quadratic formula. X equals negative b plus or minus the square root of b squared. Let me grab a calculator. What? 16 times 16, 256 minus 4 times a times c, so minus 16, all divided by 2a. 2 times 1. Alright, let's do A. Instruction A. Instruction A says find the discriminant. Discriminant is going to be what's under the square root. So I'm just going to do 256 minus 16, and that is 240. Okay, B. Describe the number and type of roots. Well, the discriminant is 240. 240 is going to fit, I think, this, number 2. It's positive, but I don't think you can do square root of 240 and get a whole number. You can't. So it's positive. That means there's going to be 2 roots. But what type are they going to be? They're not going to be our integers. They're going to be irrational numbers. 2 irrationals. Alright. Okay, then C just says simplify your formula. So here we go. I really have 16 plus or minus square root of 240 all divided by 2. Okay, now 240, you start dividing 240 by a perfect square. 240 divided by 4, 9, 16, 25, 36. And you find that you can rewrite this as 16 plus or minus the square root of 16 times the square root of 15, because 16 times 15 is 240. All that over 2. I'm running out of room. So you got 16 plus or minus 4 times the square root of 15, all divided by 2. And then for your last step, just divide both those terms by 2. So let me come over here. If you do 16 divided by 2, that's going to give you 8. And if you do 4 divided by 2, that's going to give you 2. So there, are your two roots. One of them's 8 plus 2 times the square root of 15. One of them's 8 minus 2 times the square root of 15. Alright, let's call that good.